In a previous lesson, you learned the basics of data transformation with the Pandas library. In this lesson, we're going to learn how to create conditional transforms. These are useful for recoding variables based on specified criteria. So let's get started. To start, I open up my VS Code and let's create a new file and call it pandas conditional transforms.qmd. And here is our list of learning objectives. If you like, you can pause the video, read through these, but we're going to come back to them at the end of the lesson. Let's now make a new section and call it imports. And we add in a code chunk and let's import pandas as PD, import numpy as np, import Vega datasets, from which we're going to get some sample datasets as VD, and import plotly.express as px. So press Ctrl Enter to run that. In my case, it seems I haven't installed Plotly yet in this environment, so let me do that very quickly. Open a new terminal and run pip install Plotly. And now let's make a new section and call it intro to replace. So here I'm going to show you how to use the replace method. And to do that, we're going to use the tips dataset from Plotly Express. So type tips equals px.data.tips. Put that pair of parentheses there. Let's print out the tips dataset and take a look at this day column here. So the day column consists of days, but they are abbreviated, as you can see. In order to see all the days, I can do tips and then subsets the day column and then run .value counts. And that should show me that there are just 4 days, Sat, Sun, Thur, and Fry. And we may want to recode these so they have the full names. Let's see how we can do this. We're going to use the replace method. So to use the replace method, the first thing we're going to do is create a dictionary that contains mappings from our current values to the new values we want to replace with. So let's create a dictionary called day mapping, but you can call it whatever you want. We open up a pair of braces there, and then let's map sun to Sunday, comma, Sat to Saturday, and then the other two, Thur to Thursday, and finally Fry to Friday. And now all we need to do is grab tips day, the day column, and use the replace method and give the replace method our mapping dictionary. So paste day mapping into here. And you'll see that now we have Sunday, Saturday instead of the old values. And now we can assign this to a new column. Let's call that one tips and then day full and set that equal to this current value of tips. And then let's print out the new tips data frame. And as you can see now, after day, you have this day full column that contains the full version of the original. If you wanted to simply overwrite the original, you could just run tips day equals the following. But let's run all the code above. So we re-import tips. And then now we can run this. And you'll see that within the day column, it has been overwritten with the full versions. Now, alternatively, you could also just run this without creating that intermediate dictionary. So let me just show you that. So instead of creating day mapping separately, you could have, of course, just put it directly into the replace. And this would work just as well. Sometimes it's helpful to define the mapping externally because it makes the code easy to read. But when you have just a few categories, it may be easier to just nest it directly within replace. Let me run this and make sure that it all works. And that looks to be good. Now here's a practice question for you. I want you to abbreviate the sex column in the tips dataset. As you can see, it currently contains female and male. I want you to use replace and a relevant dictionary to replace it with F and M. Assign the results to a new column called sex ABBR for sex abbreviation, and then also display the first few rows. So pause the video and try that out. Now let's open a new section and call it handling missing values with replace. So sometimes your data contains missing values like none or nan, and you want to replace those with specified placeholders. So replace can actually handle these pretty well. To demonstrate this, let's open up a new code chunk, and we're going to extract the movies dataset, this time from Vega datasets. So type vd.data.movies, and then open and close a pair of parentheses, and then let's quickly print that movies dataset. And as you can see, there's this column here called creative type. Let's see if we can find it. Creative type close to the end. And some values are none. And none is basically a placeholder for missing. To show you that that's a special type, I could just quickly write this to a CSV. You don't have to do this. Let me write this to a CSV and call it movies CSV. And I forgot to put the .csv extension. But once you put that, you could in theory open this in an Excel spreadsheet. And you will see that those values of creative type here that are none inside of Python are actually completely empty when you write it to an external CSV. So none is just a placeholder for missing. And later on, we will look at these NaN values. For example, here in running time minutes, we have NaN, which are NaN values. But those, again, are just placeholders for missing. As you can see from this column here, running time minutes, it's completely empty when you write it to a CSV. So let me return the value counts of that creative type column, just so that we can view it more clearly. So creative type with a capital T there, and dot value counts. And we need to indicate the argument drop NA equals false in order to actually count those nones. And as we can see, there are 446 missing values, 446 nones. So now imagine we want to replace these nones with a specified value like maybe unknown or unclear. We can do that with replace. So I'll open a new code section and I'm going to type movies creative type, or let me just copy that from over there. And then we tag on the replace method. And we're going to define a dictionary directly in here. In here, we're going to set none to the value of unknown/unclear. Now notice that the none is not enclosed in quotes because it is not a string. It's a special value. That's a non-existent value. Okay, so don't put that within quotes. And I can run this. And if I run this, you can see now that we have those values unknown/unclear. And let's assign this now to a new column, or maybe we can overwrite the existing column. I'm going to write movies creative type is equal to this replaced version. And then once that's done, I'll copy all of this into that cell, copy this line over here into that cell, so we can count the new column. And if I run it, you can see that none has been replaced in all cases with unknown/unclear. So let's put a comment here and say replacing none values with a string. And note that just as we did it in this direction, so none to unknown/unclear, you can also map a string to a missing value by just swapping the order of those. In a new section now, let's write a comment that says replacing NaN values with a number. And NaN values, like I showed you, is what we use to represent missing, but in a numeric context. So as an example, let's look at the US DVD sales column. So let's scroll up to where we had printed out movies. And let's look at US DVD sales. As you can see, for many of them, that value is missing and it's represented by NaN. And to see that more clearly, let's type movies and then subset US DVD sales, and then grab the tail of that, the last 10 values, and let's print that out. And as you can see, some of these are NaN. And let's see how we're going to replace those values. So I'm going to copy this little selection here, and let's paste that. And we're going to tag on the replace method, replace, and we supply a dictionary that will map np.nan to the value 0. Now notice here we are not typing NaN just like that, because this is not directly available in Python the way none is directly available in Python. So NaN is a special thing that comes from NumPy. So you have to set NP for NumPy and then NaN, and that's in lowercase. And we can just run this to print out the value. So now you can see it's 0, but we haven't yet updated that actual column. So let's do that. I'm going to set movies US DVD sales to the replaced version of it. And we run that, and maybe in a new code section, let's see the new values. So now if I look at tail again, you can see that all of those previous NaNs have been replaced with zeros. So based on that, here's a practice question for you. So again, using the movies dataset, access this MPAA rating column. Let me quickly show it to you. So the MPAA rating column, which is here, has values for the rating, so either R or 18 or something like that. Some values are none, and some values also say not rated. So I want you to replace both none and not rated with unrated. So that will require a dictionary with two different key value pairs. So in these cases, we had only one key value pair, but you need multiple key value pairs similar to something like what we did there. So pause the video and try that out. Now let's open up a new section and call it categorizing numeric data with custom functions. As you may recall from a previous lesson, we can create custom functions that will help us categorize values in a column using conditional statements like if and else if. So let's do a quick revision of that here. Let me write some text that is going to explain what we want to do. So we want to categorize the US gross variable according to the following criteria. If the value is less than 10 million, we want to categorize it as low. If the value is between 10 and 50 mil, then we want to categorize it as medium. And if the value is greater than 50 mil, then we want to categorize it as high. So let's see how we can write a function that will do this. I'm going to call my function categ_gross for categorize gross, and it will take in one argument, gross. And we put a colon, we press enter, and let's write our if-else statements. So if the gross is less than 10 million, so 10 and then 6 zeros, 1, 2, 3, 4, 5, 6, then in that case, we want to return low. And then else if gross is greater than or equal to 10 million. Let me just copy that so I don't have to count the zeros again. And remember here we use the and keyword rather than the ampersand. And the gross is less than or equal to 50 million. So let's copy this over and put in 50. Then in that case, we want to return medium. And I see I accidentally put a colon here. So let's remove that colon. And then finally, maybe one more else if the gross is greater than 50 mil, then we want to return high. And we can have maybe a catch-all for every other thing. And in that case, maybe we return missing. So we return none. Now we can try out this categ_gross function on a single value. Let's try it out on 500. That should be categorized as low. But hopefully you remember that this does not work by default on multiple values. So if you try to provide it a list or a data frame column, as we will later on, it's not going to work. It's going to give you an error. So in order to make this work on a list or a data frame, we need to vectorize it. So I'm going to create a vectorized version called categ_gross_vec. And that's going to be equal to mp.vectorize. And then we'll define categ_gross in there. And now we can use this categ_gross_vec function instead of categ_gross. And that works, as you can see, on a list. And we can try it out on a data frame. So let's now pull out our movies US gross column. And you can see that value over there. And let's apply categ_gross_vec to it. So that seems to give us the right categories. And finally, let's assign it to a new column. We'll call that column maybe category type, or let's call it a gross category. And we set that equal to this value. And now we can print out gross category and you can see those values in there. So hopefully all of that is revision. So I'm not going to give you a practice question on it. Let's open a new section and type complex transformations with custom functions. And here we're going to apply a custom function on a complex transformation that will use two columns from our specific data set. And here is the categorization we're going to try to implement. So we're going to try to grab superhero movies. And if the US sales, the US gross, and the worldwide sales are the same, that means it only sold in the US, then we'll categorize it as a US action movie. Okay. But for superhero movies where the worldwide gross, sorry, that's a tongue twister, is greater than the US gross, then we flag it as a global action movie. And for everything else, we'll just leave the flag blank. So let's see how we can define a function that will take in these values. So I'm going to define it and call it flag movie, and it's going to take in three arguments: the movie type, then the US gross, which I'll call US, and then the worldwide gross, which I'll just call worldwide. I press colon, and let's write some conditionals. So if the movie type is equal to superhero, with a capital S and a capital H there, and the US gross is equal to the worldwide gross, then in that case, I want to return US action movie. Otherwise, if the movie type is still superhero and the worldwide gross is greater than the US gross, then in this case, what do I want to return? I want to return global action movie. Okay. And for everything else, we can just return none. So else return none. And let's quickly test this out with a few values. So I'm going to grab flag movie, or let's run this cell first, run that cell. And let's test it out with the movie that's a superhero movie. So superhero, that's the movie type argument, or let me type it out actually. Movie type equals superhero. And then US gross, let's say, is equal to 100. And the worldwide gross is equal to 100 as well. So this means that the US sales and the worldwide sales are the same. So it's a US superhero movie. Let's see if it works. Indeed, US action movie. Let's try another one where the worldwide sales are more than US sales. So maybe we sold 200 worldwide and 100 in the US. So that means 100 were outside of the US. You can see that's a global action movie. And let's try something else that's not a superhero movie. Maybe it's a comedy. Comedy. And this returns nothing, so it's empty. So the function seems to work, but I guess we forgot to vectorize it. So let's quickly do that. Flag movie vec is equal to mp.vectorize and then flag movie. All right, let's run that. And finally, let's apply this on our dataset. So I'm going to grab flag movie vec, and the movie type in this case is going to be equal to the movies column, the movies dataset, specifically the creative type column, creative type, comma, then the US sales are going to be equal to movies, and then the US gross, US underscore gross. And finally, the worldwide sales is going to be equal to the worldwide gross. So let me just copy movies, US gross, and put it there, and change this to worldwide. And now let's assign all of this to a new column in our movies dataset. And let's call it movies and then action flag. All right. And that's a lot of code. Let me quickly zoom out so you can see the full thing. So that's what it looks like when you put it all together. Zoom out one more time. All right. So that's the full function. And now let's do some value counts to see how many values there are for each category. So I'm going to do movies action flag dot value counts. And we can see then that there's 42 global action movies and 7 US action movies according to this categorization. Now, based on that, here is a final practice question for you. It's a pretty hefty practice question. So you're going to again use the movies dataset, and I want you to flag movies in that dataset as either critic friendly. That means mostly critics like it, but the actual popular audience doesn't love it that much. Or commercial, which means the popular audience loves it a lot, but critics don't love it that much. And you're going to use the Rotten Tomatoes and IMDb ratings. Rotten Tomatoes is more for critics and IMDb is more for just the regular audience. Specifically, if Rotten Tomatoes rating is above 70% and the IMDb rating is below 5, then you flag it as critic friendly. That means the Rotten Tomatoes people like it, but the public audience doesn't like it. And if the Rotten Tomatoes is below 50% and IMDb is above 7, so that means Rotten Tomatoes doesn't like it and IMDb loves it, then you flag it as commercial. And then otherwise, you will categorize it as just other. And then you count how many movies are critic-friendly and commercial after you do this categorization. There should be 13 critic-friendly and 33 commercial movies. And see if you recognize any of them. I definitely recognize some of the commercial ones that were quite bad. So that's a lot of code for you to practice with. So pause the video and try out that practice question. So now let's go back to our list of learning objectives. So the hope is by the end of this lesson now, you are able to create and transform variables based on conditions using replace and mapping dictionaries. You also know how to handle missing values in replace transformations. And finally, you can define and apply custom functions to recode variables. The techniques you have now learned are very powerful tools for data cleaning and processing. Congrats on getting through this video. I'll see you next time. Bye-bye.
For more resources, visit our website, where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.